In July 2025, astronomers using the Atlas survey spotted a faint, fast-moving object, 3I Atlas, on a path that could only mean one thing: it came from interstellar space. Unlike typical asteroids or comets, its velocity and trajectory were unmistakably alien. This was only the third confirmed interstellar visitor, after Oumuamua and Borisov. The astronomical community sprang into action, redirecting telescopes worldwide to study this rare guest. Early observations hinted at a comet-like coma, but 3I Atlas was already breaking the rules. Instead of following the familiar script, it began to behave in ways no one expected. Each interstellar object is a time capsule, carrying clues about its home system's chemistry. By studying 3I Atlas, we're peering into the building blocks of another solar system, without ever leaving our own. What secrets would it reveal? Was our solar system unique, or just one recipe among many in the galaxy? The arrival of 3I Atlas was more than a novelty. It was a scientific opportunity we couldn't afford to miss. As telescopes locked on, the world waited to see what this cosmic messenger would teach us. Would it behave like a comet, or surprise us at every turn? The stage was set for a celestial mystery unlike any before. The first step was to chart 3I Atlas's orbit. Its hyperbolic trajectory confirmed it was just passing through, never to return. There was no threat to Earth. Its closest approach would be far beyond Mars, but its path gave us a tight timeline, a brief window to observe, before it vanished forever. Global telescopes, including Hubble and James Webb, scrambled to collect every possible photon. Unlike local comets, this was a one-time show. As it neared the sun, 3I Atlas began to change rapidly. We expected a classic comet, ices sublimating, a coma growing, a tail unfurling. But this object tore up the rulebook. Its approach wasn't graceful, it was chaotic, volatile, and unpredictable. The urgency was real. Every observation counted as the object transformed before our eyes. This was our only chance to study a true interstellar wanderer up close, and what we saw next would challenge everything we thought we knew. As 3I Atlas approached, NASA's images stunned astronomers. Instead of a crisp comet, they saw a ghostly, diffuse cloud, evidence it was falling apart. The nucleus was hidden in a vast, expanding haze of gas and dust. Its coma grew at a shocking rate, far outpacing predictions. Rather than steady sublimation, it was erupting in violent bursts. Powerful, focused jets, over 7, blasted material into space, hinting at a chaotic, tumbling surface. The object's brightness and shape changed daily, defying expectations. Getting worse became the refrain, not as a threat, but as a sign of its rapid disintegration. 3I Atlas wasn't just a passive visitor, it was a fragile, dynamic relic, unraveling before our eyes. We were witnessing the spectacular death of a cosmic traveler from another star. The biggest surprise: 3I Atlas lost its tail. Comets usually grow long, bright tails as they near the sun, but this one's iconic feature vanished. How could an active comet with a massive coma and powerful jets have almost no tail? One theory: it fragmented, dissolving into a diffuse cloud of debris too disorganized to form a tail. Instead of a steady outgassing, it erupted in sudden bursts, scattering material in all directions. The timeline was off, losing its tail before even reaching the sun's closest point. This forced astronomers to rethink comet physics. Maybe interstellar objects are built differently, shaped by alien chemistry and conditions. 3I Atlas was a teacher, reminding us how little we know about the universe's diversity. Its missing tail was a cosmic riddle, pushing us to question our assumptions. The universe, it seemed, still had plenty of surprises in store, and this visitor was just getting started. The real revelations came from analyzing its light. Spectroscopy showed 3I Atlas was dominated by carbon dioxide, far more than any local comet. Our comets are rich in water ice, but this one had a sky-high CO2 to water ratio. That suggests it formed in a much colder region of its home system, near the CO2 ice line. Its chemistry was truly alien, hinting at different planetary recipes across the galaxy. Polarimetry revealed its dust was unusually fluffy and porous, more like distant Kuiper belt objects than typical comets. This explained its fragility and chaotic behavior. CO2 sublimates at lower temperatures than water, so as 3I Atlas neared the sun, it erupted violently, long before water ice would even react. The result: a massive coma, strong jets, and rapid disintegration. It was like hitting a block of dry ice with a blowtorch. 3I Atlas simply wasn't built to survive our sun. Its demise was spectacular and scientifically priceless. We were witnessing the chemistry of another solar system up close. So, what was 3I Atlas really? Evidence pointed to a fragile rubble pile, a loose collection of pebbles, dust and ice barely held together by gravity. This structure made it incredibly vulnerable to the sun's heat and gravitational tugs. Its chaotic tumbling exposed volatile patches unpredictably, triggering violent outbursts. The multiple jets and wild brightness swings were the result of this cosmic dance. Most interstellar visitors may be just as fragile, disintegrating before we ever spot them. We might only see the rare survivors that make it close to the sun. The galaxy could be full of these crumbling messengers, most lost to dust before we can say hello. This fragility is a warning. Future missions to intercept such objects will face real hazards. Approaching a tumbling, outgassing rubble pile is risky business. We'll need spacecraft that are fast, agile, and tough enough to survive the chaos. 3I Atlas showed us these objects aren't just targets. They're unpredictable active environments. Studying them will require new strategies and bold engineering. The brief chaotic life of 3I Atlas was a lesson in cosmic diversity. Its high CO2 content and extreme fragility revealed that planetary systems can produce wildly different objects. There's no universal blueprint for solar systems, each is a unique experiment. Interstellar comets may be more volatile and short-lived than our local ones, shaped by their alien origins. As 3I Atlas crumbled, it seeded our solar system with dust and exotic ices, a real-time example of galactic material exchange. This process, called lithopanspermia, hints at the possibility of life's building blocks traveling between stars. The galaxy is a dynamic ecosystem, not a collection of isolated islands. The fleeting window to study 3I Atlas underscored the importance of sky surveys like Atlas. Without them, we'd miss these rare, precious visitors. The story of 3I Atlas is a call to keep searching, keep watching, and keep learning. Each interstellar object is a chance to understand our place in the cosmos. 3I Atlas's fleeting visit highlights a core truth. The universe won't wait for us. We must be ready to act fast. Every observation is a race against time. Our detection systems need to spot not just the familiar, but the truly strange. Future algorithms must flag anomalies, not just typical comets and asteroids. The next interstellar visitor could be even weirder, and we can't afford to miss it. The dream is to intercept one up close. Missions like ESA's Comet Interceptor are being designed for that very purpose. 3I Atlas's fragility makes this a daunting challenge, but also an irresistible one. These objects connect us to the wider galaxy, carrying stories from distant stars. By studying them, we learn about our origins and our cosmic family. The hunt for interstellar messengers is more than astronomy. It's a search for who we are. Each discovery brings us closer to understanding the grand narrative of the cosmos, and the next chapter could arrive at any moment.